Right. So the last time we wrapped up the chapter periodic table uh, with metallic bonding, and today it's sort of leading in from that. We are going to be doing chapter 10, which is entirely about metals.
Okay.
Right. So I'm not following the uh, chapter numbering the way they've been organized in the syllabus or the text. This is chapter 10. We haven't done chapter 4, 5, 6, 7, 8. Obviously, skipped all of those. We will come back to them. But since we did skip those, there are certain terminologies that we'll come across in this chapter that I will clarify. But the details of those terminologies will come in the respective chapters.
Okay.
All right, so we begin by giving some facts about metals. Since we've talked about the periodic table, if you take a look at the periodic table, you will notice that most elements in the periodic table are metals,
Yeah.
right? And obviously, their properties are very different to non-metals. In fact, you could say that uh, their properties compared to non-metals are quite the opposite. So if we list the properties, they are good conductors of heat and electricity. We're talking about the metals over there. Okay?
Yeah.
So they're good conductors of heat and electricity. They are malleable and ductile. Or before that, let's say they have
Conductors, as in they help with the heat and electricity, or they can produce heat and
they
electricity.
can pass it along.
Okay.
Right? They have high melting and boiling points. Or let's say usually they have high melting and boiling points. There are certain exceptions, and they are malleable and ductile. Remember these two terms? So malleable means they can be hammered into shape or made into sheets. Hammered into shapes, and ductile. Right? They can be drawn into wires. And if you talk about non-metals, then they are not good. They're poor conductors of heat and electricity. They have usually they have low melting and boiling points, and they are poorly malleable and poorly they have their ductility is also poor. So they're soft or brittle, right? And so they cannot be hammered into shape, and they cannot be poured into wires. Okay, so we have
Okay.
there's a table in the book that highlights this.
Okay.
Now, uh, right, even though, right, they have certain similar physical properties, other properties, right? So these are physical properties that are the same for most metals. But then there are other properties are different. For example, right, their reactivity with air, right?
Yeah.
So sodium, we know sodium is highly reactive, right? It's stored under oil. So,
Yeah.
right, it's so reactive that you cannot expose it to it because sodium is highly, right? It will immediately start reacting with the air. And then you've got iron, air or water, let's say. Those are two different scenarios, but still. Iron reacts slowly, so it is not highly reactive. And then you've got gold, which is pretty much unreactive.
Okay.
Right? So if you have gold in the air, right, it's left out in the open. Even if you throw gold into the water and just leave it there, it's not going to react. It's not going to form any gold oxide or any other such right compound. It's going to stay gold. Right? So
Yeah.
all these guys are good conductors of heat and electricity. All of them are potentially right. The problem with sodium is that it's so reactive that you can't get around to doing it, but potentially it is malleable and ductile, right? Uh, it doesn't have as high of a melting point as iron or gold, but again, that's why they put usually. But then their reactions differ. Or let's say not the reactions, but the reactivity differs.
Yeah.
So what we can gather from here is the reactivity differs, and this will lead us to talking about these reactions and then building what is called a reactivity series. Now, some of the reactions we might be familiar with from the periodic table, right?
Hmm.
And others may be new. So, the first thing we want to talk about is metals reacting with acid. In fact, let's take this to a new page. Metals with acids. Now, this entire chapter that's dedicated to talking about acids, alkalis, and salts, acids, bases, and salts. And we'll get to that chapter after this one.
Okay.
All right, so metals with acids. Right, and what we get to know is if a metal is reacted with dilute hydrochloric acid. What we would see is the formation of a metal chloride and hydrogen gas being produced.
Formation of?
A metal chloride and hydrogen gas. right? So the metal chloride we would be able to see, right, forming as possibly a white precipitate, right,
Yeah.
or a salt, depending
Okay.
on whether the chloride is soluble or not. So it could be a precipitate, it could be an aqueous solution, but right. And the hydrogen gas would be seen as effervescence. So that's basically, you'd see a lot of bubbling happening. Like, the bubbles you see in a soda bottle,
Yeah.
right? Those are effervescent. And if you shake the soda bottle, you see like lots of bubbles coming up,
Yeah. Yeah.
right? That is effervescence,
Mm. Okay.
right?
Yeah.
So how we would write this as, for example, let's take magnesium. So magnesium is a metal, and let's add that to acid, hydrochloric acid, and that would give you magnesium chloride and hydrogen gas. Writing that out in symbols, the magnesium is a solid, HCl is aqueous, and it will give you MgCl2, which in this case would be aqueous, so you won't find a precipitate, right? It's going to be aqueous as well, and hydrogen gas. Now, since this is an equation, let's balance it.
Yeah.
How would you balance it?
Let's see. Wait. Mg is same, and Cl has two. So we'll put two with HCl, and two in the product side as well.
Where?
In the H.
Why? H is already 2. And you put 2 with HCl. So now you've got two hydrogens on the reactant side and two hydrogens on the product side. So it is balanced.
Yeah. Yeah, that's it.
That's it?
Yeah.
Okay, good. So you have a balanced equation.
Okay.
Right? Now, what they say is that we can carry out similar reactions with other metals and see how readily they're able to react, right? And whether they react or not at all. Okay. And from that, what we end up getting, as I just mentioned, is a reactivity series. So a reactivity series for metals is the, how readily metals, right, undergo certain reactions. And as a spoiler, right, I'm going to give it to you. It's in the book, obviously, it's all in the book. But, right, this is how it goes, right? So, starting from most reactive to least reactive. Starting with most reactive, at the top, you've got potassium, which is K. Then you've got sodium. What's the symbol for sodium? Do you remember?
S.
No.
K.
K is
That was for potassium. Wait.
uh, it's natrium. It's
Na.
Latin.
Na.
Its Latin name is natrium. And then you've got calcium. What's the symbol?
Ca.
E. So potassium, sodium, calcium. Then you've got magnesium.
Which is Ma.
Huh?
M.
It's written on the whiteboard in front of you.
Oh yeah, sorry. Sorry.
G.
Yeah.
Right. Then you've got aluminum, aluminium. What do we have over here? Aluminium. Right. Aluminium
A.
is,
L.
yes.
Okay.
After aluminium, we've got carbon. Now you'll be like, wait, carbon? And yeah,
Cr.
C.
Yeah. Sorry, I missed that.
Cr is chromium.
Oh, okay.
Then you've got zinc, which is
I believe I.
I.
I. Which element had I as a symbol?
Iodine.
Oh, okay.
So zinc is,
Z.
no, not just Z.
E.
Where did E come from?
I. What was the Greek name for it? Or
ZE would be the symbol for my name,
oh yeah,
right? But not for zinc.
yeah,
Okay. Then we've got iron. Tell me this one.
yeah.
Its Latin name is ferrum.
F.
F and
E.
E. Okay. Then you've got hydrogen. Sure, you're going to make a mistake with this one. What's the symbol?
Hg.
Hg.
Yeah,
It's hydrogen. It's H. Hg is
but I mean
mercury.
H was correct. H was still correct.
Yes, Hg is mercury. Copper.
C.
C what? C is carbon. You got to add something else.
Oh,
No, Co is cobalt. The Latin name for copper is cuprum.
Kapram. So it will be Cr.
Cr is chromium.
My God,
Cu.
it's hard to keep up with the symbols.
You keep repeating them. Enough exposure and practice is going to, you find you're going to get.
Yeah.
Okay. Then you've got,
So this is all reactivity series, right?
yes.
Okay.
Then you've got silver, which is Ag, and gold, which is, the Latin name is aurum.
Ar.
So
Ar.
Ar is argon. Au. And there you go, right? So that is starting with the most reactive,
With the least reactive.
going down to the least reactive. Okay?
Yeah.
We are not done with our reactions though. Right? So since they mentioned the reactivity series, I gave it to you. And right, so with the different types of reactions we're going to go over, we understand, okay, fine. So how you would expect a certain metal to behave. So the next reaction is right with air or oxygen.
Okay.
Right, and so in general, right? Metals would react with oxygen to form oxides.
Yeah.
Form oxides. And again, so we're going to take magnesium as an example. You've got Mg plus O2 gives you MgO, it's a solid, gas, and magnesium oxide is also a solid. Balancing. How would you balance this?
Okay, let's see. We wouldn't touch Mg. So wait, we have one over there. So two for Mg.
I thought you were not going to touch it.
Wait. Let me see. Yeah, just put it there.
2 mg.
Yeah.
Okay.
So if we have two Mg, then on the product side will be also two, right?
Should I put it
Right?
2?
Right? Am I right?
No, no. I mean, you tell me, right? You got two oxygens here. You've got one oxygen here. Now, if you're making magnesium 2 as well, right? So you've got two magnesiums, two oxygens. Over here, you've got one magnesium and one oxygen. So should you put a 2?
No.
Why not? How are you going
They'll
to?
cancel each other out.
Huh?
They'll cancel each other out.
Nothing's getting cancelled. How will it get
Okay, then
cancelled?
put two. Put two. So we
Now,
have
two,
two
mag-
M.
two of magnesiums, two oxygens, and then right, again two magnesium. So yeah, this is balanced.
Yeah. Okay.
Why the hesitation?
I was doubting my answers. You were making me doubt my answers.
Well, it is part of my job to, you know, sometimes confuse you, see how confident you are.
Okay.
Okay, and
Yeah.
so right, this is a white right oxide that's formed. Okay, so that's with air and oxygen. Next up is reaction with cold water or steam. Now,
Okay.
why are they giving you two options? Cold water and steam are not the same thing. I mean, chemically they are,
Temperature wise, they have different.
yes, and so that would tell you, well, some metals are so reactive they would react when even when the water is cold. For some, you need to heat the water, so it will only react when with water if it's hot.
Yeah. Is gold? Can
Gold,
gold react
yeah, gold won't react.
with neither cold and steam?
Yeah, so right,
Okay.
even if you like put gold into boiling water, it's going to get hot, but it won't react.
Okay.
You want to try boiling some gold?
Yeah, I was thinking if it would have some effect on it.
Okay, so what you're going to get is when you react a metal with water, then you're going to get, right, and in this case, we're talking about water, not steam, right? So you're going to react a metal with water and you're going to get sodium, right, a metal hydroxide and hydrogen gas. So,
We will balance again.
well, yes, we are coming up with some equations, so we're going to try and balance all of them.
Okay.
You can get a metal hydroxide and hydrogen gas. I don't need to keep saying hydrogen gas because hydrogen is a gas, right?
Yeah.
And so, for example, you've got sodium plus water is going to give you sodium hydroxide and hydrogen. And let's do that. Sodium plus water gives you sodium hydroxide and hydrogen. So that's gas, that is aqueous, that is a liquid, and that is a solid. Now, balancing that.
We have two here, and we don't have two on the product side. So we'll put two on the product side as well.
Where?
Correct.
For this guy?
No, no, with the sodium one.
Okay.
And we'll put in the reactant side as well
Where?
with the sodium. And yeah,
You think it's balanced?
wait, we have sodium here, and we have sodium 2 on the reactant and the product side. We have hydrogen on the reactant and product side.
It's not about having hydrogen, the reactants, how many of them you have.
Yeah, yeah. But we don't have hydrogen 2 with the sodium on the product side.
No, but let's see. How many hydrogens do you have on the reactant side?
2.
Two.
Yeah.
How many do you have on the product side? There's one H and then this. So there's two hydrogens here and then two here. So you have a total of four. And let's take a look at oxygen. You only have one oxygen here, and
One oxygen here.
but then put a two. So there's two. So one here, two here. So it's not balanced here. You've got two like so sodium's fine. Okay. Right, but you've got two hydrogens here, four hydrogens here. One oxygen here, two oxygens here. What are you going to do?
Remove the 2.
No, then you're going to go back to where you started from. That's also
Then we'll add the 2
here.
near the oxygen.
Oxygen,
No, no, the hydrogen, sorry.
but that's going to increase the number of hydrogens further. It will make it six hydrogens. It's still not
We
balancing
have
it out.
we won't touch the reactant side, right?
Why not?
Because we have them with, okay, we have sodium 2,
Yeah.
we have hydrogen 2, right? Reactant side. And on the
So
product side,
compare the number of atoms of each element on the reactant and product side. Right? So
yeah,
you put a 2 next to sodium, so you've got two atoms of sodium. You put a 2 next to sodium hydroxide, NaOH, and so you've got two sodiums on the product side as well. So sodium is balanced.
yeah,
Okay. Now let's
yeah.
look at hydrogen. H2. So you've got two atoms of hydrogen on the reactant side, right?
1,
One, but two because you put a two for the whole thing,
mm,
right? So
yeah,
you've got two hydrogens here and two hydrogens here. So four hydrogen atoms on the product side. Two
yeah.
and four, right? So that is not balanced.
So we will, wait, 2 and 4. We'll remove, wait. We won't remove. We'll add 2
Here.
here, yeah,
Okay, so now you've got four hydrogen, two twos are four, so you've got four hydrogen atoms on the reactant side and four on the product side. Let's take a look
yeah,
at oxygen. There's one oxygen over here, but two of these molecules, you've got two oxygen atoms on the reactant side and two on the product side. Now it is balanced.
yeah.
Okay?
Yep.
Right. Okay, so uh, right, only the very reactive metals such as potassium, sodium, and calcium will react with. So you got potassium, sodium, and calcium that will be reacting directly with water. right? For metals in the reactivity series that are coming after calcium, so magnesium, aluminum, and all of those, aluminium, uh, right? You will, they will not react. Right? The reaction with water will be very slow, right? So, for example, magnesium, iron, zinc, they will react slowly with water. But if you give steam, they will react rapidly.
Okay.
And when reacting with steam, they will produce a metal oxide. So the reaction is slightly different. Metal oxide and hydrogen. Right, so let's take magnesium reacting with steam. That's a solid plus H2O. So, right, this H2O is a gas, so that's your steam.
Yeah.
Right, it's not in its liquid form, it's not water, it's steam. And it's giving you magnesium oxide, MgO, which is a solid, and hydrogen gas. Balancing?
That's what I'm checking. Wait. I think they are balanced.
They are balanced. It's
Yeah.
all good. Okay?
Yeah.
Now, if I take you to the book, right, and show you the table of the order of reactivity that they've given. Let's put that on screen. Can you see that?
Yes.
Zoom in further. Yeah. So this is the order of reactivity or the reactivity series, right? So you have starting from potassium, and you can see that increasing reactivity of metals. So the most reactive metal is at the top. Okay.
Yeah.
You have the most reactive, that's potassium, and then you've got gold at the bottom, which is pretty much unreactive. Gold and silver. So we talked about reactions with dilute acid, and so
What does dilute acid mean?
dilute acid means that acid is mixed into water,
Oh, okay.
right? It's mixed into more water. So when we talk about when we go to the chapter of acids and bases, right? Dilute and concentrated, basically the difference is in dilute acids there's more water as compared to the
Normal acid.
meaning as compared to the the acid molecules, so HCl, as you talked about hydrochloric acid, right? So if it's in aqueous, means it's mixed in water, so that that has HCl molecules and water molecules together. If it's dilute, meaning that there's more water than there is HCl. If it's concentrated, that means it has more HCl than water. Right?
Okay.
The more concentrated it is, the the lesser the water molecules will be.
Yeah.
Right? And then there's certain you have uh, let's say pure acid, which has just the HCl, it has no water. Right? Although in that case it doesn't behave the same way.
Okay.
Actually. Now, coming here, we talked about reactions with dilute acid. So we talked about it produces hydrogen gas with decreasing vigor, right? So the reaction becomes less, it becomes slower, and it doesn't readily react, and it doesn't produce as much hydrogen gas going down the reactivity series up until copper, right? Copper, silver, gold, they do not react with dilute acid, so it just stops reacting at copper.
Okay.
Okay.
Yeah.
There's a reason why hydrogen is given over here, and we'll understand that when we talk about when we go to the next chapter again, which is acid bases and salts. Okay.
Yeah.
So
Okay.
obviously hydrogen is not a metal, so why is it put over here? Well, there's a reason for that.
Okay.
Then reactions with air or oxygen, so that's the same thing, right? And so again, the most reactive metals, they burn very brightly and vigorously. Then going slightly down, right? We talked about magnesium. They burn to form an oxide with decreasing vigor. So again, right, the reaction is not happening as readily. Going down till hydrogen, reacts slowly to form an oxide, and then finally, right, silver and gold, they just don't react.
Yeah. Okay.
Then with water, right, so sodium, potassium, they right react with cold water to produce hydrogen, but with decreasing vigor. Then right with magnesium, you need to react it with steam, and again, right, going down the reactor. So as the reactivity is decreasing down this list, right, they are not as readily reacting even with steam. And then you reach the point where you have right hydrogen, and so they're not reacting with cold water nor steam, so they're just not reacting.
Oh, okay. Okay.
Okay.
Yeah.
And then right, they've added this column over here, ease of extraction, right? And
Meaning?
so these metals are found in the earth, right, in mines and ores, and so they are mined from their deposits, and right then they are purified and then extracted. So the metal, for example,
Basically, they're covered in dirt and everything, so they.
it's not just a matter of dirt, right? So if you want magnesium or you want calcium as like the calcium metal or the magnesium metal, or for example iron metal,
So
right?
to get that metal, you have to remove everything that's surrounding it.
Not just surrounding it physically, but everything that's reacted with, because it is not found as pure iron.
Yeah.
It
Yeah.
is found as iron oxide. It is found as magnesium oxide.
It's mixed with other
It's
things as
it's
well.
it's found with as copper oxide,
Yeah.
right? So you want it's found in generally as oxides, right? And
Yeah.
I'm going to talk about extraction in this chapter later on. So
Okay.
it is found as oxides, and so right, you want to separate the pure elemental metal, so just the iron, just the Fe, right? Just the calcium, just the copper, right? Not the oxide. So you want to remove that,
Yeah.
right? So at the top of the reactivity series, it is difficult to extract. For example, sodium is found as sodium chloride, which is, salt that right?
Yeah.
So you don't want sodium chloride, you just want the sodium metal. So how do you remove the chloride, right? But
Yeah.
potassium and sodium are very difficult to extract. Then, right, calcium, magnesium become easier to extract. And then way down, you have silver and gold, which are found as the element itself. So you have silver as silver, unreacted with anything else, and gold as gold. So the only thing in that case you need to do is clean it, as you said, remove everything that's surrounding, right?
Yeah.
You don't need to, chemically react it, so to speak.
Yeah.
The reason for that is also related to the reactivity series. Because potassium and sodium are so reactive, they they are not found in their elemental form. They react with, in like for example, sodium reacts with other elements. It's found as sodium chloride. Similarly for potassium, calcium, magnesium are found in their oxides, right? And so because they are very reactive, right, they are found in some other form other than the elemental form. Okay. But right down, right up till copper, even though they are found in their right reacted forms, because their reactivity is less. So whatever they're found as, it is easy to purify. It is easy to extract. Whereas silver and gold we've seen throughout, they do not react. They don't react with dilute acid, they don't react with air, they don't react with water. And so they are found unreactive, just as the element itself.
Okay.
Again, right? We will talk about extraction of metals later on, and so that would probably help, uh, right, with the understanding. Okay, just to wrap this up,
Mm-hmm.
uh, right? So as they say, generally it is the unreactive. So right, the less reactive a metal is, the more it can be used by us, right, to make things. And that is why iron and copper are very commonly used in everyday objects. Right, there are exceptions such as magnesium is used in the construction of the Airbus A380. Right, so that's an exception. Aluminum is an odd case. Why is it an odd case? It's high up in the reactivity series. So let's actually in the middle of the reactivity series, but higher up, right? So it's coming here. But it is
Yeah.
not as reactive. Why is it not as reactive? The reason why is that it's actually so reactive, right, that it very quickly forms a protective oxide coating on the surface. And once that coating is formed, right, it does not, it prevents further reactions,
Oh, okay. Okay.
right? It's like you wearing a sweater,
Yeah.
right? Winter is coming. Well, not in Sharjah, it's always hot, but
Yeah.
yeah. So you taking a shawl or a sweater or something, and so right, you don't feel cold anymore. Not the best
Yeah.
analogy, but still, right? So because of that, aluminum has particular uses because it is a light metal, it is strong, right? It is a good conductor of heat and electricity, obviously, and so that's why it is used in the manufacture of aircrafts because of its low density. It is used in the manufacture of overhead electric cables, again because of low density and good electrical conductivity. And it is used as food containers because it is resistant to corrosion. So it already has an oxide coating on it, and it's not, that's going to prevent further reactions from happening. So it's not that aluminum is not reactive, it is reactive, but it is, in this case, it reacts so quickly with the air to form an oxide coating that it doesn't readily take part in other reactions,
Okay.
right? So just that, and interesting for some reason, right? Uh, the details over here and over here are pretty much the same. They just mentioned that sodium and potassium are so reactive they need to be stored under oil to prevent them from coming into contact with water or air, right? And they have low melting points. So, right, sodium, potassium are exceptions to the general high melting point, high boiling point uh, quality of metals. So they have low melting points and are good conductors. So yeah, all metals are good conductors of heat, and so they are used as coolants for nuclear reactors. So just a bit of information about
Okay.
it. Okay,
Yeah.
and so yeah, I'll stop here for the day. And tomorrow, remember displacement reactions. We talk about displacement reactions for halogens,
Yeah.
and the metals can
Yeah.
metals on the reactivity series can also be used displacement reactions. Again, right, the displacement reaction is dependent on how reactive the metal is, right? So again, this involves the reactivity series that we just covered. So we'll get into this tomorrow, inshallah, and then move forward.
Okay.
Any questions?
No.
Right. See you next class then.
Okay.
Allah Hafiz.
Bye.